Safe to call multiprocessing from a thread in Python. According to this URL, and is there a safe way to create a subprocess from a thread in Python? The Python multiprocessing module does not allow use from within threads. Is this true? My understanding is that it's fine to fork from threads, as long as you aren't holding a threading.lock when you do so, in the current thread, anywhere in the process. However, Python's documentation is silent on whether threading.lock objects are safely shared after a fork. There's also this, locks shared from the logging module causes issues with fork. This URL. I'm not sure how this issue arises. It sounds like the state of any locks in the process are copied into the child process when the current thread forks, which seems like a design error and certain to deadlock. If so, does using multiprocessing really provide any protection against this, since I'm free to create my multiprocessing.pool after threading.lock is created and entered by other threads, and after threads have started that using the not fork safe logging module? The multiprocessing module docs are also silent about whether multiprocessing.pools should be allocated before locks. Does replacing threading.lock with multiprocessing.lock everywhere avoid this issue and allow us to safely combine threads and forks?
It sounds like the state of any locks in the process are copied into the child process when the current thread forks, which seems like a design error and certain to deadlock. It is not a design error, rather, fork predates single process multi-threading. The state of all locks is copied into the child process because they're just objects in memory. The entire address space of the process is copied as is in fork. There are only bad alternatives: either copy all threads over fork, or deny forking in multi-threaded application. Therefore, forking in a multi-threading program was never the safe thing to do, unless then followed by exif or exit in the child process. Does replacing threading.lock with multiprocessing.lock everywhere avoid this issue and allow us to safely combine threads and forks? No. Nothing makes it safe to combine threads and forks. It cannot be done. The problem is that when you have multiple threads in a process, after fork system call you cannot continue safely running the program in POSIX systems. For example, Linux manuals fork 2. After a fork 2 in a multi-threaded program, the child can safely call only async signal safe functions, see signal 7, until such time as it calls exif2. I.e. it is okay to fork in a multi-threaded program and then only call async signal safe C functions, which is a rather limited subset of C functions, until the child process has been replaced with another executable. Unsafe C function calls in child processes are then, for example, malloc for dynamic memory allocation, NE, studio.h, functions for formatted input, most of the thread underscore functions required for thread state handling, including creation of new threads. Thus there is very little what the child process can actually safely do. Unfortunately, Python core developers have been downplaying the problems caused by this. Even now the documentation says, note that safely forking a multi-threaded process is problematic. Quite an euphemism for impossible. It is safe to use multiprocessing from a Python process that has multiple threads of control provided that you're not using the fork start method. In Python 3.4+ it is now possible to change the start method. In previous Python versions, including all of Python 2, the POSIX systems always behaved as if fork was specified as the start method. This would result in undefined behavior. The problems are not limited to just threading.lock objects but all locks held by the C standard library, the C extensions, etc. What is worse, that most of the time people would say it works for me, until it stops from working. There were even cases where a seemingly single-threading Python program is actually multi-threading in Mac OS X. causing failures and deadlocks upon using multiprocessing. Another problem is that all open file handles, their use, shared sockets might behave oddly in programs that forks, but that would be the case even in single-threaded programs. TLDR, using multiprocessing in multi-threaded programs, with C extensions, with open sockets etc. Find in 3.4 Plus and POSIX who explicitly specify a starting method that is not fork. Find in Windows because it doesn't support forking. In Python 2 to 3.3 on POSIX, you'll mostly shoot yourself in the foot.
If you want to see more, please consider subscribing.